Soften your senses. Ways to become a better speaker, listener, and follower. This episode brought to you by Tru Tech Tools. A sign of a true technician is the quality of their tools and their ability to use them. Learn more at TruTechTools.com. Well, hello everyone. Thanks for joining us once again. Today we're hanging out with our good friend Eric Kaiser from Tru Tech Tools. Eric, how are you, sir?
Doing real good, Clifton. Thanks for having me on the show today.
Absolutely. It's a lot of fun when we start talking about how the industry has changed. I'm not going to say we are we are experienced technicians.
We got some, yes, one or two or three experience anyhow.
We got a few years out in the field, and the one thing that I can say both of us have been able to witness is the evolution of tools in our industry.
It really is. In our time in the industry, and I've been in almost 20 years now, and you've probably been in a little longer even than that, we have seen such a change in tools.
Yeah, oh man.
When I got into the industry, there was barely any digital tools with regards to like pressure gauges and things like that, mostly all analog.
Everything.
There was no Bluetooth. There was none of that.
Eugene and I were just joking on the show yesterday that I actually learned how to read wet bulb with a sling psychrometer.
Oh, yeah.
And carried a bottle of a little gallon of distilled water in my van for when I was measuring wet bulb.
Yeah.
My first recovery unit had 4 wheels, and you had to change the oil on it every time you used it.
Mine had a roll cage. It was a giant red thing called a Reclaim, I think, but it had all the filters and everything.
Yes, that may have been the same kind of equipment.
I mean, the thing weighed probably 50 or 60 pounds. And trying to drag that on a rooftop.
Oh my gosh.
And
yeah, I still have my charging cylinder that still has R12 in it.
wow.
Like my original charging cylinder. So I've been able to gather up some of my original tools from, it was a family-owned business that I started in, and now one of the sons is running it, and so some of the older stuff has just been sitting around, and Bob was gracious enough to give me some of our old items that we had, been using in the past, and so they're still as relevant today as they were then. It's just much easier with tools of modern technology.
It's much easier, and it's also more accurate, and it can also be faster too.
Oh man, yes.
Which accuracy and speed is something that is of a concern, especially as we move towards higher SEER, more efficient equipment. We're really trying to dial the performance in, dealing with tighter houses. So now we're dealing with tighter shells. We're actually dealing a lot with lower capacity equipment today, because as we tighten houses and buildings up, the capacity of the equipment that we need to condition those spaces actually goes down.
Much less, which is wonderful.
Yeah, it's great for everybody. The units are getting bigger because they're higher efficiency, but the capacity we need for those spaces is going down. We need better tools to analyze those structures to be able to figure out what capacity units go into them. There's just a multitude of things that we couldn't even accomplish even 10 years ago, much less 20 or 30 years ago.
And I think that's been the most interesting thing, is you're exactly right. 10 years ago is when we really started diving into higher performance. And I would consider these high performance tools much different than some of the things that we have utilized in the past. We were setting charges with systems and we were getting pretty close. Today, we're talking about critical measurements down into the ounces of refrigerant going into a system and dialing these into optimal performance. So the need for the accuracy in the tools is what has escalated so much, and the software that drives those things have evolved just as fast as every other form of digital technology.
They really have, and software in this is key because it is taking all of the readings simultaneously. It can take 20, 30 readings simultaneously on a system, combine it all in, and give us as a technician or the human operating it all the information in the same place, and or start making decisions or helping us make decisions about what to do, whether or not that system is operating properly. You take something really popular, still is for a lot of people, and I ran the calculations on this recently, and just because I was curious. So depending on what kind you use, now this is an analog gauge, refrigerant gauge, and a thermocouple probe. And I took the two specifications for those because, like, say we're calculating superheater subcooling, and now we have two instruments, and we're taking the reading from both of those instruments, and we're making a calculation with them. But now, when we talk about accuracy, we have to deal with the inaccuracies, the potential inaccuracies on two pieces of equipment, not just one. So now we have a compounding inaccuracy potential. Okay, and this is brand new right out of the box. So I took two pieces of just off-the-shelf tools, calculated it out, and when I looked at the calculations that I ran, was for a subcooling, I think for 410A, running around 110 degree condensing temperature, which would end up being a 100 degree line temperature, which is not really unheard of, especially with some of the heat we've been.
Yeah, absolutely.
But the potential inaccuracy for a 10 degree subcooling was plus or minus 4.8 degrees Fahrenheit.
Wow, that's pretty significant when we're setting a critical charge in a system.
So, and the question I had to ask myself then was, I'm thinking about all these systems I've worked on over the years. I've looked at those manufacturers. So all the systems that I've worked on over the years, and I'm looking at the specifications and thinking about the specifications on that. I'm thinking back to what was the plus minus specification on a subcooling reading that manufacturer wanted.
I know the company that I installed, and we're talking 20 plus years ago, it was plus or minus 2 degrees.
So plus or minus 2 degrees, those instruments can't even achieve that accuracy.
Man, I haven't really thought about it from that perspective, but absolutely.
So we have to know, accuracy. What is that? And realistically, that goes to customer expectations, because if we come up to a customer's house and we're working on a customer's piece of equipment as a technician or as a company, they expect us to have accurate instrumentation. They're expecting us to make accurate tests and give them accurate information.
Yeah. What do we do when we go to a doctor's office? We have expectations of a professional diagnosis.
Right. We expect them to have accurate instrumentation to give us as a patient to make a decision.
Yeah.
Sometimes we go with their advice. Sometimes we don't. I've gone against the doctor's advice because I didn't think it was best for me in my situation. And homeowners can do that too, and that's fine. I don't have a problem with that. I give them information. It's their money.
Right.
But we have to be able to give them accurate. And if we give inaccurate information and they make a decision based on that, we are taking responsibility for that decision because we gave them inaccurate information.
Absolutely.
Tools give us inaccurate information. As you can see, it cascades down there.
Sure. We always talk about, validation, and the only way that you can validate something is to actually measure it. And the only way that you can have changes is if you have corresponding information that validates the original readings, right? And so accuracy really becomes compounded because I need to accurately know where I'm beginning so that I can accurately read the results so that I can give a proper diagnosis or at least a proper result from what changes have been made to something.
Yeah. Yeah, especially if you're doing before and after measurements.
Yeah.
Not only do we have to be accurate, but we need to be precise as well. And a lot of people confuse those two terms. So accuracy, I think of like a target and shooting bows and arrows at a target.
Sure.
And accuracy is hitting the center of that target. Whereas precision may be shooting all those arrows in a tight group, but it might not be in the
Could be
middle of
anywhere
the
on
target.
that.
It could be anywhere
Yeah,
on the target.
sure.
So we need to be both precise and accurate, hit the middle of the target with all of our readings or all of our diagnosis and measurements, things like that. And that it really becomes very important. And it was something that I didn't think about for a lot of years.
No.
Being in the field. And as I've grown, as I've learned, and now as I'm spending, all my time around tools, I'm actually really starting to dig more into this and realizing that, hey, I could have done a lot better in the field. But now I've got this knowledge and I need to come out here and share it with everybody else so that everybody else can learn it, learn faster and learn from others, because one of my favorite ways to learn is from others' mistakes.
It's a lot cheaper and easier. So let's talk about, as this evolution of tools is happening right in front of us, in the past, at least, my experience from the residential and light commercial side is if we're in a service van, if we're in a company provided van, typically the company is going to provide some of the larger equipment, recovery, vacuum pump. But when it comes down to what we consider hand tools, a lot of us as technicians have to provide our own hand tools and gauges. And I know it can be very expensive, but let's talk about the repercussions of not investing into proper tools.
So not investing in tools, I mean, it's kind of like not investing in yourself.
Yes.
It's kind of like not investing in your house, right? If you don't keep up and put quality products on the outside of your house or into the structure of your house, you might get a roof leak on your head. I mean, you might get a roof collapse in the middle of the night.
That's right.
I remember a story from a friend of mine who was a coal miner when I was a kid. And he was literally laying in bed one night with his wife and his ceiling fan fell out of the ceiling.
Oh.
Now he rolled over, mumbled something about, the roof's falling in. We got to bolt that back up, because that's what they do in coal mines. They run these long bolts up in to hold the roof up. His wife didn't think that was very funny though. But whatever it was that didn't get done right on that ceiling fan, I don't know the whole backstory to that.
Sure.
Ceiling fan fell out of the ceiling in the middle of the night. And that to me was always like, hey, somebody didn't do something really right. I started falling down on top.
Some procedure was not followed properly here.
But that's what I consider investing in good tools, investing in good knowledge, because those are both sides of it. The tools allow us to do things that we can't do maybe with our bare hands. They're an extension of our bare hand. If we're trying to physically manipulate something, do something, we can't take screws out with our fingernails most of the time, 99.9% of the time, unless the tools are really stripped out on that rooftop from somebody hitting it with too many ugga-duggas. And then they just fall out sometimes. But we have all these things that are extensions of ourselves.
Yes.
To do this job faster, to do it better, to do it easier. We could go around and take screws out all day long with a handheld screwdriver, but nobody does, because now powered screwdrivers. If we look back at the old timers, if somebody ever comes across sheet metal ducts with flathead screws in it.
And there are still some out there.
There's a little bit out there. But if you ever see those, and you think about how they had to put those screws in.
How much time?
Every single one of those holes was pre-drilled with a hand drill, not a power drill, a hand typically. And then the screw was put in with a manual screwdriver, because they didn't have power screwdrivers.
90 degrees at a time.
Yeah. And they used ratcheting screwdrivers.
Yeah.
Those were very popular.
Yeah, that's true.
Because holy cow, all those screws, you might count hundreds of thousands of screws in a duct system.
Yeah.
And I think back at that and I look at how easy we have it today. So realistically, I know some of the listeners on this show are also instructors. So I think it's very important from a school level, from an education level in the schools, to be teaching this new technology. I hear a lot of instructors on a regular basis say, we have to teach them the analog. And that's great.
I know.
Teach them the analog way.
Sure. But
maybe right at first,
yeah,
but then let's get some exposure into those tools that they're actually going to be using in the field, because analog may do good for an emergency, or an older tool may do good for an emergency, but we have to keep up with the technology that they're going to be handed by companies in the field. Now, personally, I've worked for a number of different companies. Some of them provided a lot of tools. Some of them provided a very little bit of tools. And I own a ton of tools of my own, just because I kept buying. And a lot of the companies, I find, they were hesitant to buy tools because technicians, let's face it, sometimes we're not the easiest on tools.
True.
And I prefer to have a partnership between myself and the company where I own the tools and they'll replace them if.
And I've done that too.
Now, if I lose the tool on the job,
that's on me.
That's my responsibility. But if I break the tool on the job, that's a different thing. Or if I wear it out, something like that, batteries go bad, they get worn out over time, then the company pays to replace it. But it's my tool when I go. And then the reason I like that is because I have that. Now I know what I'm dealing with. I get to pick and choose somewhat. Now, today, a lot of companies are starting to standardize test equipment
across
their platform.
Yes, so all technicians are using the same things. They can teach on it. They know what to order for service materials.
Right, and they can keep backup tools at the office. So if something does go bad, because let's face it, just like the equipment that we work on every day, this stuff wears out and it goes bad. It breaks.
It's just a tool.
It is. It's a tool. It's not going to last forever. Even the really old stuff that we like to say lasts forever doesn't
last forever. They all require maintenance. And when we talk about these new tools, we have to be very realistic, especially, as educators. I hear the same thing all the time. If we don't teach the fundamentals, they're never going to understand it. And that is so true. And I truly believe on teaching with mechanical gauges and thermistors to calculate basic superheat and subcooling. But at the same time, we have to be realistic about the capabilities of modern tools and technologies. And really, if we think about it, are you going to ask a Gen Z to buy a mechanical tool when they have grown up with digital? Everything they know is digital because it is accurate and because it is faster. So it's not really realistic to put the expectations of our own learning into the hands of a new generation who learn in a different manner. Is it right or wrong? Well, that comes down to your own evaluation of what tools that you think are appropriate. I personally like to teach on both. I like to show the mechanical. I like to show the digital in all aspects, just so that they see the fundamentals. But when they get out into the field, what are they going to buy?
They're buying digital.
And that's exactly right.
I mean, they're used to digital. They're used to phones.
It feels natural.
It does. It feels very natural. It's very comfortable to them. You and I, we kind of grew up in an analog age.
Absolutely.
We lived that transition.
Yep.
We started out with dial telephones and transitioned to push button telephones, and now we have touch screens. And so we're kind of in I would say, somewhat of a unique generation in it, that we can bridge that gap a little bit easier. But I do like, and I agree with you, teaching on some of the older technologies, because I think it gives an appreciation for where we're at today as well.
It does.
It shows how far we've come.
Yep.
And I embraced digital, especially refrigeration gauges, but I have really embraced the digital and the technologies as we've gone forward. I started with digital refrigeration gauges in about 2004.
Yeah, I think somewhere in that ballpark it would have been about the same.
Not 2004, 2007. I'm sorry,
yep.
2007. And I still own them today. Still own the first pair, and they're still just as accurate as the day I bought them.
Yeah,
take it. And they got beat around in the back of trucks in rainstorms, you name it. They're still kicking around. Quality lasts for a long time.
Exactly. And we have come a long way with the quality of our test instruments. And I just hope everyone understands that we are evolving as an industry. There are things that are going to, transition away from. When we start talking about tools and people are hesitant to move to new technologies, I ask how many of our educators are using the mechanical voltmeters, the analog voltmeters, the non-RMS voltmeters that they grew up on. And very rarely do we see those still being used in our programs. We might use them as a history lesson, but when it comes to practical application, I'd say they're all using digital multimeters.
They better be using the digital equipment if they're getting anywhere near frequency drives and things like that, because of you've got to have that true RMS.
100%.
The averaging meters don't work today with what we're trying to really measure out here. And if we want any kind of accuracy or precision, that's
the caliber. All right. Eric Kaiser, we sure appreciate you joining us today, and we look forward to many more discussions on the evolutions of tools. And where can everyone find Tru Tech Tools?
TruTechTools.com. Thanks, Clifton.
Awesome, man. I appreciate your time.